So now we're gonna talk about the pH. Now pH of strong acid we have already seen. Now pH we're gonna see in a mixture of strong acid. Whenever we have a mixture of strong acids, so whenever we are mixing, so an aqueous solution, we write some sentence, an aqueous solution of mixture of strong acid and the concentration of H plus ions are produced by strong acid unless when very. So an aqueous solution, a mixture of strong acid and H plus ion. So what does it mean? That whenever the solution is dilute, like whenever you have a solution like strong acid HA, and here you have another solution, a strong acid of HB, and you are mixing both of them. So an aqueous solution, let's say you have a very dilute solution. So if we go into calculation of pH, so let's say it is HB, we write it as HB. When you mix both the HA and B, let's say it's molarity is M1 and volume is V1, and molarity is M2, volume is V2, and you're mixing both of them. So molarity, let's say M final and volume is V final, and V final might be equal to V1 plus V2, or we have taken some sample from V final to some volume. Let's say it is V final. Let's say it is V1 plus V2. I mean, we are mixing both of them, right? So what happens? The concentration of H plus in the initial container and the HB1 container should be the M1V1. So moles of H plus from HA plus moles of H plus from HB should be equals to moles of H plus in final solution, right? So what is the moles of H plus? Molarity multiplied by volume, M1 multiplied by V1 plus M2 multiplied by V2, that is equals to M final V1 plus V2, right? So molarity final, or we can say concentration of H plus final, turns out to be M1 V1 plus M2 V2 divided by V1 plus V2. But what if we have a lot of containers containing the strong acid? Remember, we are right now talking about strong acids only. If you see, so the series of this continuation of ionic equilibrium, we are doing everything from very basic to proceeding step by step. So first we learn how do we calculate the pH of a strong acid. Now whenever we are mixing both of them, but when we are mixing a lot of containers containing the strong acids, so concentration of H plus turns out to be sigma MiVi divided by sigma of Vi, summation of Vi. So that is the concentration of H plus, and M1 V1 plus M2 V2 plus M3 V3 and so on, and V1 plus V2 plus V3 and so on. That is how we came to know the concentration of H plus, and concentration of OH minus turns out to be Kw divided by H plus. Now this was the concept, right? If there are some variation in problem, then you may remember your basics of mole concepts also, right? Like we're gonna see some problem. We'll see some example. Calculate H plus concentration of OH minus ion concentration and pH of solution of mixture of strong acid solution obtained by mixing of 200 ml of 0.1 molar HCl and 800 ml of 0.05 molar H2SO4. So this is the illustration. Now I'll encourage all of you to first try to solve by your own. Pause the video and look at the solutions. So let's talk about the solution. We mixed 200 ml of 0.1 molar HCl and 800 ml of 0.05 molar H2SO4. So H plus coming out to be same as the mole of H plus, because HCl dissociates into H plus and Cl minus. So 1 mole gives this 1 mole of H plus. So the moles of H plus comes out to be, right, from HCl is 200 into 0.1 millimole, and mole of H plus from H2SO4, because H2SO4 will give 2H plus SO4 negative 2. 1 mole of H2SO4 will give 2 mole of H plus. So we will multiply here by 2 into 800 into 0.05. We are calculating the concentration of H plus divided by total volume. Now volume total comes out to be 200 plus 800. That is, if you solve all this, we will get 100 by 1000. That will be 0.1. So pH comes out to be 1, and concentration of OH comes out to be 10 to the power minus 13, right? So pH 1 and concentration of OH minus comes out to be 10 to the power minus 13. So that's how you see a lot of problem when we are mixing both the strong acid.